Hi everyone, welcome back. Today we're going to look at another example on how to solve a second order non-homogeneous differential equation. In this example, we're going to look at where your equation is equal to some function which is a sum. So here we have our second order differential equation. We know it's the second order one because the highest derivative is the second derivative, and it is equal to a function, and you see that this over here is a sum or a difference. It works out to the same thing. Then we know that because this is non-homogeneous, we know that our solution has to equal to complementary function plus particular integral, right? So for our complementary function, we can write our differential equation in the operator form, d squared plus d minus 6 y cf equals to 0, right? So then our auxiliary equation is going to be d squared plus d minus 6 equals to 0. So now we want to find the roots of this equation because that will tell us what the form of our complementary function is going to be. So we're going to have two brackets, d 3, 2, and plus minus, which means that d is minus 3 and d is 2, right? So our roots are real and different, which means our complementary function is going to look like this, right? Then for our particular integral, we know d squared ypi plus dy pi minus 6 ypi has to equal 12x minus 50 sine x. Right? And we need to choose a trial function so that if we find our first derivative and our second derivative and substitute in, the equation has to simplify to 12x minus 50 sine x. So let's choose a particular integral. Now, if you see here, you've got two terms in this function, and this function is made up of the first term, which is linear, and the second term, which is trigonometric, which means your trial function has to be made up of the same thing. So your linear one will be cx plus d. Your trig one is going to be made up of sine as well as cosine. So plus d e sine x f cos x, right? Then our first derivative is going to be c e cos x minus f sine x. The second derivative is going to be minus e sine x minus f cos x, right? And then we're going to substitute into our equation. So I'm just going to put a little tail here and say that that is equation 1, right? So I'm going to substitute into 1, and we have minus e sine x minus f cos x. Second term is going to be plus c plus e cos x minus f sine x, and then we've got minus 6ypi. So it's going to be minus, I'm just going to multiply out in one go, cx minus 6d minus 6e sine x minus 6f cos x, and that must all equal to 12x minus 50 sine x, right? So now we need to simplify. And the way we do that is we look for all the like terms. So what we've got here, we have sine terms, we have cos terms, and we've got a constant. We also have a x term over here, right? So I'm going to start with, let's look at the x term. because you see there isn't another one. So we can find a solution almost immediately for that one. So minus cx has to equal 12x, right? So we've got cx. I left out a 6. Don't forget that 6, which means that c has to equal minus 2. Okay? Then we've got our constants. It's going to be c and d, right? So c minus 6d has to equal to 0, right? Which means minus 6d has to equal minus c. D is equal to c of 6, which means it is going to be minus 2 over 6, which is a third. Right? Let's always just double check. So, yes. Okay. Now, let's move on to the trigonometric values. Get a different color here. So, we've got sine terms and cosine terms. So, all our sine terms, sine, and sine have to equal minus 50 sine. Right? It's always useful to draw the terms, the like terms in different colors, or like a squiggle and a straight line. It just makes it easier for you to see. And then you'll also know if you've finished with a section, right? It just makes it easier. Okay, so then let's look at our sine terms, I said. So minus e sine x minus f sine x minus 6e sine x must equal minus 50 sine x, right? So minus e minus f minus 6e has to equal minus 50. So minus f minus 7e must equal minus 50. Okay, so then let us first have a look at the cosine terms and see what we get. So we've got cosine, 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 and that is going to equal to 0 because you don't have a cosine term on the other side. Okay, then we've got, let's see, minus f. Let's just move this up a bit so you can also see. There we go. Minus f cos x e cos x minus 6f cos x, and those must all equal to 0. Right, so we've got minus f plus e minus 6, which means minus f plus e minus 6f has to equal to 0, which means that e is going to equal 7f. Right? Let's put that one away so long. Okay, so I'm going to take this e value and substitute it into this equation here, right? Because you have two equations, this one, and two unknowns. So then you can solve. So minus f minus 7 times 7f is equal to minus 50. That is going to be 49, so that's going to be minus 50f equals minus 50, which means f has to be 1, right? Which means e has to be 7. Right, so we've got all our values. So then ypi is going to have to be, let's just bring this one back. We remember that our trial function is made up of a linear part plus a trig part, right? So then c, we remember, is minus 2. So minus 2x, d is minus a third, right? That's our linear part. And then E, let's just remember where E was with sine. So it's going to be E plus 7 sine x plus cos x, right? And then our final solution is made up of the complementary function plus that particular integral. And our complementary function, let's see, what did we get? Looked like this, right? So it was ae to the minus 3x, be to the 2x, and then our particular integral, 2x minus a third, 7 sine x plus cos x. And that over there is the general solution. So just to recap, if you have your non-homogeneous differential equation equal to some sum, you must then break up the sum or the terms in that sum into different types. So in this case, in this example, we had a linear term and a trigonometric term, which meant that our trial function was also made up of a linear part and a trigonometric part. I hope that made it clearer to you. I'll see you next time. Bye.